So, bringing up energy. Energy is a fundamental part of change. And so we need to have a basic idea of what energy is. We won't go as far into it as you do in physics. Energy can be defined as the capacity or the ability to do work. But then we also have to define what work is. Work is defined as the action of a force through a distance. So nothing really to do with jobs, right, or getting paid money. When this man pushes this box, he's applying a force to the box and moving it a distance. He's doing work. If he stands there and pushes on the box, but nothing moves, it's not actually work. So force acts through distance and work is done. There are different types of energy. There's lots and lots of types of energy. The two main categories we are interested in are kinetic energy and potential energy. So kinetic has to do with motion. Kinesiology is the study of the human body and how it moves, right? Kinetic energy is the energy associated with motion. So any object in motion has kinetic energy. Then we have potential energy, and that's associated with its position, or it can also be associated with the composition of it. So here in this picture, we have this big 10-kilogram weight teetering on top of the building. This has the potential to fall, right? If we give it a little nudge, it's unstable, it's not going to stay up there, it's going to fall down. So up here, it has a lot of potential energy. Energy of one kind can be transformed into other forms. And so as this weight falls to the ground, the potential energy goes down and the kinetic energy goes up because it goes faster and faster. And then what happens to all that energy when it hits the sidewalk? Most of it goes to thermal energy. The weight itself and the sidewalk will be warm. That energy will dissipate as heat. That's not something you might necessarily notice unless you were under. But actually, even if you were under there, you probably wouldn't notice because you might be dead. Right? So you wouldn't notice a little temperature change. That's not what I meant to do. Well, I unhighlighted those, whatever. So thermal energy is associated with the temperature of an object. Thermal energy is actually a subcategory of kinetic energy because thermal energy has to do with the motion of the individual particles. So I mentioned, the 3 states of matter and the 3 states of chemistry students, and right now you guys are in the solid state. And I'd say the temperature in here is pretty low. Everybody's pretty chill. Yeah, that's my doorbell at home. Awesome, I don't need to know that right now. When a substance is cold, the particles aren't moving very much. So you guys are all pretty still. But towards the end of the lecture, you're going to be a little antsy, It's like, I really need to get up and stretch, and you're just wiggling and just trying to stay awake. Wiggling, right? You're not moving relative to each other, but there's a lot more motion. That would be like a higher temperature in a substance. So it's kinetic energy because the particles are moving within the substance. It's different than like the whole substance flying through the air. So thermal energy is a kind of kinetic energy. Any questions about that? So we can talk about the total energy that something has as being the sum of its potential energy and its kinetic energy. And so just like we had a law of conservation of mass, there's a law of conservation of energy, which says that energy is neither created nor destroyed. It can change from one form to another. It can flow from one object to another, but the total quantity of energy is constant. We observe that objects with high potential energy tend to be unstable, and they tend to change in a way that lowers their potential energy. So we mentioned composition as a factor in potential energy. So that would be called chemical potential energy. And that has to do with the electrostatic forces that hold the particles together. So we'll learn that atoms themselves are composed of charged particles, but you can also have ions and localized charges in molecule, and all of that electrical charge has a lot to do with whether something is a solid or liquid at room temperature. And it also has to do with whether it will burn easily or not. So things with high chemical potential energy, like gasoline, will very easily undergo a chemical reaction and release that energy, often as heat. Whereas something with a lower chemical potential energy, like water, does not do a lot of spontaneous changing. You can melt it and freeze it, but it's not going to just do a lot of chemical reactions where it's going to do anything with energy. So here we have a car. This is the old-fashioned gasoline car, right? So we've got molecules of gasoline in the gas tank, and those have energy because of the potential instability within the molecules. When the gasoline burns in the engine, that chemical potential energy is turned into kinetic energy, where it's making the pistons go back and forth, but a lot of it is also turned into thermal energy. If you've driven a car, well, a gas-powered car, you probably know that the engine gets hot after it's been running a while, and sometimes it gets too hot, right? Radiator boils over, and then you've got a mess. So that kinetic energy is what we want, and that's what's going to push the car forward. But a lot of the energy that was originally in the gas is going into heat, and some of it will come out in the exhaust as those molecules moving as well. So we always have energy conserved in a chemical or physical change. It doesn't get created or destroyed. We're not talking about nuclear changes, that's different. And systems with high potential energy tend to change in a way that lowers their potential energy, and that energy gets released into the surroundings. And I'll just give you a little sneak peek into Chem 1B. Anytime that we change energy from one kind to another, we lose the usability of some of it. The heat that gets generated in this engine is not doing anything useful for us, right? So we had all this energy, and in the process of using it, we essentially lose some, not to the universe doesn't lose energy, but we lose some to usefulness because the heat is not a useful form of energy for what we're trying to do. And they call that the heat tax. Anytime you switch types of energy, you get taxed.